Hello there guys and welcome back. This is Science Also. In this video we're going to talk about vectors. This video includes how to represent a vector, vector addition, negative of a vector, calculating resultant and finding components of a vector. If you want to get notified when we upload videos like this, press on the subscribe button right now. So let's start. First, let's see how to represent a vector. To represent a vector, you need a suitable scale. For example, let's say we represent 1 Newton in 1 centimeter. So 1 centimeter is equal to 1 Newton. That's our scale. Now let's say we need to represent this vector. Start from anywhere in space and draw a line parallel to the original vector. So this has 5 Newtons. We have the scale which we made that 1 centimeter is equal to 1 Newton. So we must draw 5 centimeters to equivalent the amount of the newtons. So we can mark this as the initial point and this as the terminal point. The arrowhead represents the direction. So how to symbolically represent a vector? Let's say this line starting from O and ending at A is a vector. So we can represent this as OA with the arrow on the head. So the arrow on the head matters. If the line moves from O to A, then the arrowhead is from O to A. If the line moves from A to O, the arrowhead is from A to O. Now let's see vector addition. Now how to add these two vectors? First, we must arrange them. Then keep your finger on the start of one vector. Run your finger until the line ends. So after we complete this 3 Newton line, next we can see an arrow. So the finger must move up. Okay, since there are no more vectors, we can join the initial and terminal points. Now let's calculate it. You see that this triangle is right angle triangle. So we can apply Pythagoras theorem to find the value of r. So square root of 3 squared plus 4 squared is equal to 5. So the value of r is 5. So that's not enough. We must find the angle also. You can apply the relation as tan theta is equal to 4 over 3. So tan theta is equal to 1.333. Use the trigonometric tables to find the value. Theta is equal to 57 degrees and 7 minutes. So remember this. If you saw two vectors like this, you must first arrange it in order. Or like this. So now let's see negative of a vector and vector subtraction. If we multiply a vector by -1, it means that the magnitude is same, but the direction has changed. Let's say the vector AB towards right. If it was -AB towards right, then we can change its direction as BA. Likewise, let's do this example. In this example, you can see that this 5 Newton is a negative. So in order to do calculations, let's flip it. The negative became a positive and the direction changed. So let's follow the previous procedure to get the value. First arrange, then run your finger, then connect. Use the Pythagoras theorem to find r. You get square root of 12 squared plus 5 squared, which is equal to 13. Now let's find this particular angle. Tan theta is equal to 5 over 12. Use the trigonometric tables as theta is equal to 22 degrees 37 minutes. So now let's combine both vector addition and negative of a vector to do a sum. Pause the video now and give it a try. Here we see that there are two negative vectors. Let's make them positive by flipping sides. Okay, now as you can see there are two pairs of vectors which are similar to each other. In previous classes you learned that vectors in the same direction can be added directly and vectors in the opposite direction can be subtracted directly. So here, these two vectors combine to give 4 newtons towards left, while these two combine to give 4 newtons towards up. As we did before, we can combine 4 newtons towards left and 4 newtons towards up together. So we can apply Pythagoras for this to find the value of r. Now let's step into something a bit different. How to find the resultant of two vectors which are not perpendicular to each other. Okay, consider this. Let's randomly name them. This vector is P, this vector is Q. and the angle at the center is theta. So how to find the resultant force? There are two equations which you must memorize. They are r squared is equal to p squared plus q squared plus 2pq cos theta. Tan alpha is equal to q sin theta divided by p plus q cos theta. So alpha is this angle. There is a way to derive these two equations, but I won't do it in this video. I will do it in a separate video because this video might be very long. So let's apply them to several problems. Consider this example. So your goal is to find the resultant force, which is r, and the angle, which is alpha. Let's write the first equation in order to find r. R squared is equal to p squared plus q squared plus 2pq cos theta. Let's substitute the values. P is 4 newtons and q is 3 newtons. The value of theta is 60 degrees. So 4 squared is equal to 16. 3 squared is equal to 9. 2 times 4 times 3 times cos 60 is half, so it is equal to 12. So the value of r is root 37, which is 6.1 newtons. So let's apply the next equation to find the angle alpha. Tan alpha is equal to q sin theta divided by p plus q cos theta. This would give us 5 sin 60 divided by 4 plus 3 cos 60. After simplifying, you will get tan alpha is equal to 0.4724. Find alpha, which is 25 degrees 17 minutes. So that is how we find the resultant of two non-perpendicular vectors. Remember that before applying these two equations, the vectors must either converge or diverge. They cannot be like this. If they were like this, then you must adjust them. Okay, so now let's move into our final part, finding components of a vector. So consider this vector of 5 newtons. It has two axes, x and y. It makes an angle of 60 degrees with the x-axis. To find its x component, keep your pen on the vector like this. The tip of the pen must point towards the arrow. Now there are two things you must remember. A simple thing. Towards the angle, cos, away from the angle, sine. So here the value of the vector is 5 newtons. Move the pen towards x. So now you see that it's moving towards the angle. So it's cos. So the x component is 5 cos 60 towards right. Let's simplify it. 5 times half, which gives us 2.5 newtons towards right. Now let's find the y component. Keep your pen and move the other way around. So away from the angle means sine. So the y component is 5 sine 60. Let's simplify it. 5 times root 3 over 2 towards up, which gives us 2.5 times root 3. Root 3 is 1.732, so 2.5 times 1.732 towards upwards gives us 4.33 towards up. Okay, simple. So there we go, we found both x and y component. Now let's move into something which is a little bit complex. Okay, don't panic. Let's do it together. First, let's find the x component. 1 newton towards right plus 2 cos 60 towards right plus 4 cos 60 towards left plus 5 newtons towards left. So now when we simplify, be careful. So 2 cos 60 is 1 newton, 4 cos 60 is 2 newtons, 1 newton plus 1 newton is equal to 2 newtons towards right. 5 newtons plus 2 newtons is equal to 7 newtons. Now let's find the difference, which gives 7 minus 2. Now do the same to find the y component. 3 newtons towards up plus 2 sin 60 towards up plus 4 sin 60 towards up plus 6 newtons towards down. So let's simplify this. 2 sin 60 is root 3 towards up and 4 sin 60 is 2 root 3 towards up. So root 3 plus 2 root 3 gives us 3 root 3. Root 3 is equal to 1.732, which means 3 newtons towards up plus 5.196 towards up plus 6 newtons towards down. So 8.196 towards up plus 6 newtons towards down. Let's find the difference, which gives us 2.196 towards up. This is the y component. So now let's find the resultant of the total system. Let's combine the x and y components. Now we can find r using the Pythagoras theorem. You will get 5.4609 newtons. The angle is tan alpha, which is equal to 5 divided by 2.196. Use the trigonometric tables to find it. So alpha is equal to 66 degrees and 2 minutes. So this is all for the vector analysis. We ran through the most important parts and I hope you can understand. Thank you for watching. See you guys soon in another interesting video. Until then, bye bye.